We have already looked at the ideas of sketching limits. We have seen how to interpret a feature of a graph given limit information when we have found limits. But let's go ahead and look at two more examples just to review that, as well as I wanted to give you the idea of how a question might be worded and what's wanted when the question is worded in that manner. So here, our example 1 is to sketch the graph of a function f satisfying three criteria. The limit as x goes to 2 from the left of my function is 1. The limit as x goes to 2 from the right of my function is 3. And f of 2 is equal to 0. So let's go ahead and draw some axes, some coordinate axes here. And I'll go 1, 2, 3, 4, 5 up there, down 1. I'll go to the right, 1, 2, 3, 4. And here I have room to put the relevant features. First of all, I know that as x goes to 2, my limit is supposed to be 1. That means I should have a circle at the point 2, 1. And we'll worry about whether that circle's filled in or not later. But I know that from the left, I have to approach that circle. That is, I have to be going toward that point 2, 1, because the limit as 2 goes from the left of my function is 1. My next limit is that as x goes to 2 from the right, I'm supposed to have 3. So I should also have a circle at the point 2, 3, and I should be approaching that circle from the right. Finally, my last piece of information is that f of 2 is equal to 0. That means I should have a point on the graph 2, 0. That's what f of 2 equals 0 means, that when x is 2, y is 0, I have that point there on the graph. So that means my two circles above would have to be open circles, and the rest of what happens on my function is not specified. So it might look like that, it might look like that, but this picture then illustrates an example of a function for which limit as x goes to 2 from the left is 1, from the right is 3, but f of 2 is 0. Now let's look at example 2. Here my three pieces of information are that the limit as x goes to 0 of my function is minus infinity, the limit as x goes to 4 of my function is 1, and f of 4 is equal to 2. So let's go ahead and draw what the graph might look like. I'll put up my coordinate axes. I've got to go to the right of 4 here. And I've got to be able to go down a ways, certainly. And I need to be able to go up as far as 2. So that ought to do. Alright, so let's look at first the limit as x goes to 4. I'll save the vertical asymptote for a little bit, but let's put points on the graph first. So I'll do limit as x goes to 4 of f of x is 1. So I'll put an open circle here at the point 4, 1. Now I know that I need to approach that from both sides, approach that hole. Also, I know that the value of the function at 4 is 2, so I don't get to fill in my circle. I'll put in a point up here. And also, then I'll go back to my vertical asymptote that is at 0. So since we have an infinite limit there, I'll go ahead and draw that as a vertical asymptote at 0. And here we are approaching that vertical asymptote on both sides, notice, toward minus infinity. So I just need for my graph to go down toward minus infinity, again, on both sides of 0. Now what it looks like elsewhere, again, could be anything. But this is the sketch of a graph of a function that satisfies our three criteria. Now in the future, we will have additional information that we will combine with limits in order to get a fairly complete picture of what a graph looks like. But at this point, we're interested only in this piece of how the graph would look given certain limit information.